I got 57 for my first one. I got 116 here. If I kept going, I would have a little less than 180, so maybe like 175 right here, and I'd keep on going. And if we look at everybody else's, how close are you guys to 57 whenever you see that? Like, pretty close, or, like, raise your hand if you're within, like, 5 of that. Pretty much everybody. How about for 116? Within 5? Okay. 175, are you within 5? Okay. Almost everybody is. So do you think it matters how big the circle is? Right. It doesn't really matter how big the circle is because, yes, if you have a bigger circle, you got to go further around, but your radius was longer, right? So it's proportional, and it doesn't seem to matter what radius we had. So we should know, it says, what do you notice here? We should notice that our angles are similar, even though the circles are different sizes. Okay. Also, whenever you look at those like lines you drew on your circle, do all those angles look pretty much the same? Like all your slices of your circle look about the same pieces of pie? Except for some of you have exactly 6 pieces of pie. I think Connor only has 5. I think Connor might have messed up over there.
Like one of my strings is just a little bigger.
Okay. So some of you have exactly 6 pieces of pie. Like your angles are 60, 120, 180, 240. Like they go up by 60 each time. I saw a few of you that looked like that. Some of the rest of you have a gap. So like, let me see. Michaela, yours has a gap, right? Yeah. Michaela's has a little bit of a gap like that. How many of you have one that has a little bit of a gap? Okay, so I told you guys that there is the right answer. Like, if we were all perfect, we should all be getting the exact same thing. But some of you may cut your string a little bit too long or too short. Some of you may have not lined things up quite right. You might not have measured quite perfectly, right? But we're getting in the same ballpark no matter what size circle we have. If I look here and see how many lengths of string would it take to get to 180 degrees. What do you guys, like Michaela's right here, like she's got 3 lengths of string gets her to 175, right? So hers, if I was answering for her, because I didn't quite, well, mine was about the same as Michaela's, because I also had 175 for that last angle. Hers, you would say a little bit more than 3. Some of you may have exactly 3, or just slightly under 3, but it should be close to 3, whatever you have. So, in this case, each length of string is called a radian. Now, there is a correct answer to this. Like if you were perfect, there is a correct answer. How many degrees are in that whole circle? 360 degrees. So 360 degrees is not 6 radians. Not 6 radians. So if yours was perfect, if you got exactly 6, then yours is not right. You're off a little bit. You're close, but you're off a little bit. 360 degrees equals 2 pi. What is pi? What's the decimal approximation? 3.14. If I double it, it's 6.28. So you should have 6 radians and a gap that's about 0.28 radians. Okay? Think about our formula for our circumference, because that's what we're finding with our little strings, right? Circumference either equals pi times the diameter, or the circumference can equal 2 pi times the radius, right? And so we should have the radius 2 pi times for this. So if you have a little bit of a gap, you are the winner. You did the best on this because yours matches what you should get the most. If you don't have a little bit of a gap right there, then you were probably just measuring off just a little bit, not a big deal. So we should get 360 should be exactly 2 pi for this. So when we're talking about radian degrees, this is what we're talking about. This is what it looks like. So each one of those angles you have on your circle, so where did I set mine? Each one of my angles that I have right here, like, yes, when I measured it with a protractor, I got like 57 degrees for this. But it should be, if I measure it in radians, it is 1 radian. And then this angle right here, that would be 2 radians. So when you're using radian degree instead of degrees, or when you're using radian measure instead of degrees, it is the angle that would go with 1 length of the radius, and then 2 lengths or 3 lengths there. So the whole circle is going to be 2 pi. Now, something that becomes a little bit more useful to use than 360 equals 2 pi. If 360 equals 2 pi, how much does just pi equal? 180 degrees. So half of that circle is pi radians, right? The whole circle is 2 pi. Half of the circle would just be pi for that, which becomes very useful. This one is going to be more useful for what you're going to be doing for your assignment tonight. So everything in this class that they're going to ask you is going to be measured in radians. So we may still look at degrees a little bit because in a lot of science classes and stuff they'll use degrees instead of radians. So I might still throw them in a little bit there. The only thing they might possibly ask you to use radians for is they might ask you to convert degrees to radians for that. So that is what we're going to work on tonight. So you guys will have a delta math. And it should be a fairly short delta math. What I'm going to do is just pull up the assignment and work out a couple of these. So if you want to like write this on the back of the paper or something, then you can. I'm going to go to my student view, second period. All right, and you're going to convert radians to degrees and degrees to radians. I think converting radians to degrees is very much the easiest. Especially, I like the way Delta Math teaches to do this. It makes a lot of sense to me. So you've got 7 pi over 4 radians. Okay, so radians, I know that I know that pi radians equals 180 degrees, right? So the way Delta Math teaches this, and there's several different things that you can do for this, but I like the way Delta Math does this. This pi radians right here equals 180 degrees, right? So here's what they do for these. They change 7 times 180 degrees over 4.
So you just like
You can just replace pi with 180 because you got pi radians, which equals 180 degrees. And so if you do this, you can use a calculator on this. So you got 1260 over 4, which will give us 315 degrees. Okay, there are lots of other ways to convert radians to degrees, and if you prefer a different one, go for it. You can set up proportions, you can do a lot of different things. You could probably find 10 different ways to do this on the internet if you want. But this is one of my favorite ones I found. Now, we do have a problem when we run into one like this. Convert the angle -4 radians to degrees. Oh, man, this one does not have a pi. So are you going to be able to convert this the way we just did? If it has a pi, just change your pi to a 180. You're good to go. But this one doesn't have a pi. We've got -4 radians. So how many of you have had chemistry? And in chemistry, you've done like unit conversions, right? Where you change, I hope, like, you change like, yeah, and you've done like feet per second, changed to meters per hour, or like feet per second, miles per hour, maybe things like that. So when you do that, you have to multiply by like a conversion factor. So if I know 180 degrees equals pi radians, right? So right now I got -4 radians. I'm going to put that over 1 because it's not a fraction, but I can put anything over 1 and make it a fraction. So what I want, if I've got radians on top, I want to put radians on bottom, and I want to switch those radians to degrees right there. So this has, what I'm multiplying by has to be a conversion factor. It has to be something that equals 1 so it doesn't change the value. But 180 degrees and pi radians are equal to each other. So I can multiply by that and it doesn't change the value because 180 degrees divided by pi radians is 1 because they are equal to each other, right? So if I'm going to put 180 on top. I'm going to put pi on the bottom. Radians cancel. I just multiply across. So I got -4 times 180 is going to be -720. On the bottom, I get pi degrees. They tell us to round to the nearest tenth here, so I'm going to type that into the calculator. 720 divided by pi gives me 229.183 degrees. That keeps on going, but it tells us to round to the nearest tenth, so that should be negative. So negative. If you do second and the to the key, so hit the blue button and that button right above the division, the one you use to raise it to exponents, there's the pi there. So I would have 22.183. I'm sorry, 9 and a negative. And it said rounded tenths, so I better put a 2 right there. It's going to tell me it's wrong. And so I get that one right. So if there's no pi, you've got to do it this way. If you are going, I know we're about out of time if you need to pack up while I'm looking. If you are going degrees to radians, 540 degrees, I'm going to multiply by that conversion factor again. This time I need degrees on the bottom and radians on the top. And so I'll do pi over 180, which is going to give me 540 pi over 180. If it says express your answer in simplest form, they don't want you to do a decimal. So 540 over 180 will reduce to 3, or it divides to 3, and you get 3 pi. So you would type in 3 pi over here.
Is that the only thing you have to do for degrees to radians, or is there like another thing? Like, you know how...
That's it. Just do that every time. Pi over 180 for degrees to radians.
And then for radians to degrees, it's either 180 over pi or the other one?
It's either 180 over pi, or just replace your pi with 180. 180. Yeah. But the 180 over pi will work every time as well. Like, yeah, it will, yeah.
So you don't need to replace it.
You don't have to replace it if you don't want to. It's just kind of quick to do it that way. So,
Did you record it?
yes, I did. There is also